So for this problem, it says the function f of x equals 2 times 2 to the x was replaced with f of x plus k, resulting in the function below. So you have to understand that this f of x plus k is this graph. So when you think of something being added to the end, you know that this is either up k units or down k units. And when I say k units, I mean whatever number that is. So, for example, if it was f of x plus positive 7, then that would go up 7. If it was f of x plus a negative 3, that would go down 3. So anytime you see a curve like this is an exponential curve, we need to know what this looked like to begin with. So if you think about it, this is the point you need to concentrate on for exponential curves. If it was a parabola, you would focus on the vertex. In this case, that number right there is 0, negative 3. So we need to find out where this was when it was graphed on this axis. So how we find that would be a y-intercept. You would put 0 in for x and then solve. So remember, anything to the 0 power is 1. So you do exponents first, so that would be 2 times 1, which would end up being 2. So 0, 2 would be on the f of x curve. F of x plus k, excuse me, that ordered pair shifted down 1, 2, 3, 4, 5. So that means k has to be negative 5, because that would move it down 5 units. Okay. Number 12, suppose that the function f of x equals 2x plus 12 represents the cost to rent movies. X number of movies a month from the Internet Movie Club. Michaela now has $10. How many more dollars does Michaela need to rent 7 movies next month? So when you look at this function, you know that x stands for the number of movies rented. So if she wants to rent 7 movies, then we would plug 7 in for x. Oh, sorry, that should be 12. And get 14 plus 12, which is 26. So f of 7 equals 26. Now, that means it's $26 to rent 7 movies. But she has $10. How much does she need? Would be $16. And you would get that by 26 minus 10 equals 16. Now we talked about this earlier, but what would the slope represent in this problem is it would mean $2 per movie, because if she rented 7 movies, she's paying $14 to rent those movies. This $12 was like a flat fee, so like a membership fee. So you might have questions that ask you to interpret the slope or y-intercept. That's kind of how you do it in context of the problem. But this answer would be 16. All right, 13. The larger leg of a right triangle is 3 centimeters longer than its smaller leg. The hypotenuse is 6 centimeters longer than the smaller leg. How many centimeters long is the smaller leg? So first off, you have to know what a right triangle is, and a right triangle has a 90-degree angle. This is called a leg, this is a leg, and this is the hypotenuse. Now you should know Pythagorean theorem, which is a squared plus b squared equals c squared. And in this case, it would be the leg squared. Here, let's call that a and b and c. So the larger leg of the right triangle is 3 centimeters longer than the smaller leg. So let's call this the smaller leg. Let's call it x. The larger leg would be 3 centimeters longer than that, which would be x plus 3. And the hypotenuse is 6 centimeters longer than that, so x plus 6. Now we need to find x. So what we know is this. So we would do x squared plus x plus 3 squared equals x plus 6 squared. The only parentheses that are necessary is this set and this set because this is a binomial, but it's a good habit just to put it around everything. So x squared would go here, and then x plus 3 squared is not x squared plus 9. You would write that twice. And then x plus 6 is the same thing. You would write that twice. Now our overall goal is to solve for x, so we're going to have to simplify this. That would be x squared, and then you would distribute this out, which would be x squared, and then 3x. And then take the 3x through, which would be 3x plus 9 equals, this would be x squared plus 6x plus 6x plus 36. And then you would put like terms together. X squared, and x squared on this side would be 2x squared plus 6x plus 9 equals x squared plus 12x plus 36. Now, when you have two x terms, meaning x squared and x, those can't go together. But you can simplify this by each side, so I could subtract x squared to get x squared on this side. Now subtract 12x to get negative 6x. And then if you have two x terms that can't go together, you have to put everything on one side and set it equal to 0. So you would subtract this 36, and that would get you down to negative 27 on that side and 0 on the right. Now you can solve by x by factoring. If you have an x squared term, then it would factor to x, and something that multiplies to be negative 27, and then in the middle would give me negative 6 would be negative 9 and positive 3. When you get this far, you're almost done. X plus 3 equals 0. X minus 9 equals 0. You set each factor equal to 0, and then you would solve for x. So here you would get negative 3, and adding 9, you would get 9. So those are the candidates for answers. It says find the length of the smaller triangle. Now, or the smaller leg of the triangle. Mathematically, this thing has two answers. Negative 3, if you put it in for x up here, would give you a true statement, and 9 would give you a true statement. But when I'm talking about the length of a leg, it would have to be positive. So this one would cancel out, and 9 would have to be the length of the smaller leg. If it asks you for the larger leg, you would just do 9 plus 3, and that would give you 12. So the answer to this is 9. All right, number 14. Katie and Jennifer each started, they're playing a game. They each started with 100 points. At the end of each turn, Katie's points are doubled. At the end of each turn, Jennifer's points increase by 200. At the start of which turn will Katie first have more points than Jennifer? All right, so let's make us a Katie and Jennifer table here. So they each start with 100 points. And then we'll say x is the number of turns. So then Katie will have 100 points, and at the end of each term, her points are doubled. So what does that mean about her equation? Well, the number of points would start with the 100. And this is kind of like doubling. We did this when we did exponentials. You know, at the end of the first term, they started with 0 or 100 points, and at the end of one term, she would have 100. But at the end of the second term, she would have 200. At the end of the third term, she would have 400 because they double each time. So really what's happening is you're doing 100 times 2, and then you're taking that answer times 2, I'm taking that answer times 2. So what that mathematically ends up being is 100, and then 2 times 2 raised to whatever turn you're on. Now, the difference in Jennifer is she increased by 200 points each turn. So you would do plus 200 times the number of turns. So her points are very linear. So she would have 100 and then add 200 to get to 300 and add 200 to get to 500 and add 200 to get to 700. So she's going up 200 points each time. So at the end of 0 turns, she has 100, 1, 2, 3, so on and so forth. This equation, you could plug anything in for x and find out how many points she has, and same for this one. So the question is, at the start of which term will Katie have more than Jennifer? Well, logically, if I keep going with that, at the end of the 4th term, she has 800. 5th turn, she has 1600. 6th turn, she has 3200. Let's see what happens here. If I want to skip down here, 4, if I add 200 would be 900. 5 would be 1100. So let's compare here. 300 to 500. At the start of which term will Katie have more points? Katie has 400, she has 500, so that's not it. The 4th term, Katie has 800, and she has 700 points. So Katie has more at the start of the 4th term. Okay, so this is the equation that you could get there, that you could use to get there, and you could just keep plugging stuff in. But logically, you should have been able to get this table without the equations. Okay, so this one, Alex walked 1 mile in 15 minutes, and Sally walked 3,520 yards in 24 minutes. In miles per hour, how much faster did Sally walk than Alex? So Alex walks 1 mile per 15 minutes, and Sally walks that many yards in 24 minutes. Now I need to compare these in miles per hour. Oh, sorry, this should say 1 mile. Okay, so miles per hour. So in Alex's, I need to get this converted to miles per hour. If you think about exponents and fractions, remember when you have the same thing top and bottom or across from each other this way, you can cross them out. So if I put minutes here, that would cross out. But what I'm trying to get that is turned into an hour. So what I'm trying to say here is 60 minutes is in 1 hour. So as you can see, this is a true conversion. 60 minutes are in 1 hour. The minutes would cross out here, and I would have 60 miles in 15 hours. So what that converts to is that is 4, I did it again, I'm supposed to say miles. That converts to 4 miles per hour, which makes sense. If she can walk 1 mile in 15 minutes, that's 4 miles in 1 hour. All right, now for this one, I need to get this into miles per hour. So watch this conversion. Let's concentrate on this. Let's get that to hours. So 60 minutes is equivalent to 1 hour. And I know those would cross out. And then it gives you this conversion. 1 mile is 1,760 yards. So I want to multiply that by 1,760 yards because that yard will cancel with that yard. That many yards is equivalent to that many miles. And then I can do the work. So if you did 3,520 times 60, you would get that. And then if you did 24 times 1760, you would get that. And now you have, so you would have 2,112 over that. So now you just have to divide those two. If you want to divide by the thing that's above it, you just hit second and answer, and you would get 5. So that is 5 miles in 1 hour, and that works because the units cancel out. So it says, how much faster does Sally walk than Alex? And that would be, the answer would be 1 mile per hour. Okay. Next problem. If you notice, this is a radical, and these answers all have exponents in them. So if you'll remember the rule, that if you had something like this, that becomes, let me put a there, that becomes x to the a over n. So this number becomes the bottom number. So here it would be 8 raised to the, remember if I don't have an exponent, it's 1, to the 1/3, x to the 2/3, y to the 3/3, and z to the 4/3. Right there, I hope you would be able to find the answer. 3 over 3 would reduce to 1, 4 over 3 can't reduce, and 2 over 3 can't. So there's those 3 things right there. 8 to the 1/3 is 2. You can double check that by putting it in your calculator. But remember that index number means what raised to the 3rd power gives me 8. And 2 times 2 times 2 gives me 8. So this is your answer. Number 17, a lot of you did this just by logic. You buy a box of candy bars. The box contains 50 candy bars. Each box costs $30. How much does the school have to charge for the candy, that should say bars, to make a profit of $10 per box? Well, a profit is above and beyond what you paid for it. So if you have purchased the box for $30, you need to make $40 in the candy bars. So essentially, $40 equals, and then how much could you sell each candy bar for? So 50 times what would give me $40? Now all you have to do is divide by 50. So 40 divided by 50 would be 0.8. So the answer is going to be C. If you do not know that, you can just test it out. So if I did 0.4 times 50, that's going to give me $20. So I would make $20. I would get $20 if I sold them for 40 cents a piece. Well, I'm not breaking even there. I paid 30 for them. I only got 20 back. If I do 50 cents times 50, I get 25. So I'm still in the hole because I purchased them for 30 and got 25 back. If I do 0.8 times 30, or 50, excuse me, I get 40, and 40 is how much I would gain back, and I spent 30, so I made a profit of 10. All right, number 18, it gives you a formula, and then it just tells you to find M. So that means get it by itself, and you do that by dividing by c squared. It would cross out over here, and you'd get E over c squared equals M, which is this one. Number 19, suppose that the equation V equals this represents the value of a car from 1964 to 2000. what year did the car have the least value? So I hope when you see this, you think it's a parabola because it's x squared and it's positive, so it's turned up. So what I would do here is I would go to y equals and graph it. Just to see what I'm dealing with. Now, I might not be able to see it right when I hit graph, but I probably could help myself out a little bit there. So notice I'm going to take the time to go back through it and check to make sure I put it in right, and there is a mistake right there. That was supposed to be an 8. That's a huge difference. Okay, I think that's right. And I hit graph, and like I said, might not be able to see it, but if you hit zoom and go down to zoom fit, there is the graph. Now I still can't see it, but if I hit trace and I'll just go to the right, make it move over there. I'm going to see it till it shifts up, or till I see it turning up. And right there it starts turning up. Now, I would like to see below it a little bit, so let me teach you something new here. If you go to Window, and you go to Y minimum is this y-axis, and how far do I go down here? So I'm going to change that since it's 997 and I can't see it. I'm going to push it lower than that to maybe 800. And that's the Y minimum there. And then when I hit graph, well, I can start to see it a little bit. I want it to zoom out a little bit more. So let's go maybe to 500. And that's a little bit better. What year did the car have the least value? Now, here's the value over here, and here's the year. So what we're looking for is going to be that ordered pair right there. So how we find that, we're going to do second calc and go to minimum. Go to the side of it, hit enter. And then go to the right side of it. Hit enter, and then you want it to guess that point. And it says the point in the middle is 11, 11.06, I can't read that, 967 maybe, 967. So what that means is this is the year and this is the price. So the year is 11, and that doesn't mean year 11. That doesn't mean the date is 11. That means 11 years after the initial, or when it started. So the value of the car started at 1964. 11 years later, that is when the car reached its minimum value. So 11 plus 64 is 1975. Okay. And number 20, anytime you have an exponent raised to an exponent, it says equivalent, you multiply them. So 1/3 times -3/1, that becomes -3/3, which becomes x to the -1. Anytime you have a negative exponent, you can make it a fraction like this, push it to the bottom, and it becomes positive. Since you don't have anything left on top, you got to put 1 as the placeholder. So the answer would be B.